So let's continue. End of nth year, I already deduced that I will have something like this. I will have a sum that's like this. So now, if I just rewrite this as 1.05x plus 1.05 square x plus plus 1.05 n minus 2x plus 1.05 n minus 1x plus 1.05 nx. You can see that it's the same thing. I'm just switching the order because we are always used to the smaller terms on the left, right? Now, what kind of series do you notice? What kind of series do you think this is? A GP, right? Because there's a common ratio. Then 1.05 becomes 1.05 square. Then of course it will become 1.05 cube all the way. So there is a common ratio. So it implies that this is a GP. If it's a GP, let's recall what is the formula for GP that will help us solve this question. Since this is talking about a sum, a series, so I have to use the sum to n terms formula. So for GP, the sum to n terms formula is n r to power n minus 1 over r minus 1. You must know what is the formula before you can solve this successfully. So you need to know this. So based on this formula, now I'm going to solve this question. A is my first term. So my first term is 1.05x. So I write 1.05x. My common ratio is 1.05r. So 1.05. This n refers to number of terms. And in this case, there are n terms here. How do you know? You can look at the previous note. When it's first year, I have 1 term. Second year, I have 2 terms. Third year, 3 terms, and so on. So if it's n years, I expect n terms. Don't always assume it's n. You need to double check and make sure that it's in the n. Sometimes it may be n minus 1. So here I know the number of terms is n, so I write n. Follow the formula minus 1 over r, which is 1.05 minus 1. So if you simplify this, you'll get 21 1.05 to power m minus 1 times x dollars. So I have shown part 2. Alright, so now let's look at part 3. Part 3 says, after how many complete years will he have for the first time at least 12x in his account? So since I have a general formula for the amount at the end of n years, I can simply use part 2 to solve part 3. So I need 21 times 1.05 to the power m minus 1 times x to be at least 12x. Take note that at least means greater or equal. This is the meaning of at least. So with this, I'm just solving an inequality, which shouldn't be that difficult. So here I see x on the left and on the right. Alright, so I have a 1.05 to the power m minus 1 greater or equals to 12x divided by 21x. So that gives me a 1.05 m minus 1 to be greater or equals to 12 over 21. So next, I bring the 1, right? I plus 1 to the left, plus 1 to the right. So I have 1.05 n greater or equals to 1 and 12 over 21. Now, in order to solve n, I have to add log on the left and on the right to bring down the power. So n log 1.05 is greater or equals to log 1 and 12 over 21. So my m will be greater or equals to log 1 and 12 over 21 divided by log 1.05. And this value here, right, so that means n is greater or equals to 9.263. So they say after how many complete years? That means you need a whole number. So you know you need at least 10 years in order for this to happen. So have at least 12x. So therefore, my answer is 10 complete years. At least 10 complete years.